Good evening, ladies and gentlemen. My name is Eeshan KULKARNI and I'm the third year PhD MBA student in the Graphene Research Center. The topic of my thesis and the topic of today's presentation is Graphene for Infrared Sensing, introducing flatland carbon to the unseen universe. What do I mean by unseen universe? Well, if we take a look back at the spectrum of electromagnetic radiation, we see that the infrared is all of the stuff that our eyes can't see. It is invisible thermal radiation mainly. What is graphene? Well, graphene is carbon in flatland. It is a single layer of carbon atoms, only a single layer of carbon atoms arranged in a hexagonal lattice. It is highly transparent, also very flexible and electrically and thermally conducting. Now what we've done is use this for infrared radiation sensing, and we've taken a slightly different approach to the rest of the world. Now the rest of the world uses graphene as the active layer. When light hits graphene, when radiation hits graphene, it gives off a little pulse. But the problem we find is that graphene is 97% transparent. So why on earth would you try and use a material that's transparent to try and detect radiation, regardless of its sensitivity? So we took a little different approach. We put it together with a dedicated sensing layer to detect infrared radiation more sensitively than anyone else has done in the past. Here's a bit of a look at the structure that we use. So we put graphene, the little black squares there, on top of a pyroelectric infrared sensing layer, and we actually started to notice something a little bit fascinating. We started to see that in comparison with other pyroelectric detectors, our graphene one actually became a little bit faster. We could chop the radiation at much higher frequencies, and there was no degradation in the signal quality all the way until 700 Hertz. So we dug a little bit deeper and we looked at perhaps there's a degradation of signal to noise ratio. Maybe it means that graphene isn't as sensitive. But no, we found that it's just as sensitive as anything else. It's just that it allows it to become faster, and this is directly as a result of its IR transparency. So ours is the only sensor in the world that can achieve full sensitivity even at higher chopping speeds, enabled only with the use of graphene as a transparent electrode. And you may be wondering, what can you do with some of these IR sensors? Well, the cool thing is that the material we use to detect the radiation is also optically transparent. You can't see it, it's visually transparent, but it detects infrared radiation. So all of a sudden, now you have a completely transparent infrared sensor that can do stuff like human-machine interfaces. I could be waving my hands in front of the screen and controlling it. You can also do completely optically transparent thermal vision for things like cool night vision glasses and all sorts of other biological sensing that previously you couldn't do before the use of graphene. So that's all I have for you today. We have 3 key points, and I thank you very much for your time.